Good morning. Today I have come with this topic. The topic is law of multiple proportions. This is my third lecture video on the subject chemistry of 10 plus 2 level. So first you will study the law of multiple proportions, then you will get the explanation, then example, and of course few exceptions are there to this law. So last topic will be exception of the laws. Okay. Law of multiple proportions. The first video lecture was on law of conservation of mass. Okay. Second one was law of constant proportions or law of definite proportions. And this is the third lecture. It is on law of multiple proportions. This law was proposed by John Dalton, scientist John Dalton, in 1803. Okay, this thing you will get everything you will get in your books. So what is the law? The law is like that: if two or more elements combine together to form one compound, if two elements combine together to form two or more compounds means more than two, okay? If two or more compounds, then the different masses of one element which combine with a fixed mass of the other bear a constant ratio. Bear a simple ratio, not constant ratio, bear a simple ratio. Okay. What is the meaning bear a simple ratio? If ratio is 1:2, this is simple. If ratio is 1:2:3, this is also simple. If ratio is say 1:6:8, this is also simple. So these are simple ratios. So this was stated in the law of multiple proportions. What was the law? Again I want to repeat the same thing, that if two elements combine together to form two or more compounds, then the different masses of one element which combine with a fixed mass of the other bear a simple ratio, not relation, ratio. Okay. So example I have given you: 1:2, 1:2:3, 1:3:2, 1:4:5. These are simple ratios. Okay. So explanation is what? Suppose I have taken one element, name of the element is X. I have taken another element which is denoted by Y. Suppose X reacts with Y to form three types of compounds, different compounds. Compounds are what? Compounds are say denoted by, I am very sorry, not small a. Compounds are, I am writing here, compounds. Okay. Compounds are suppose A, B and C, denoted by capital letters, capital A, capital B and capital C. These are the compounds. Okay. When X reacts with Y, X is one element, Y is other element. Okay. In different three conditions, they produce different three types of products, A, B and C. But when you are talking about the mass, suppose a fixed quantity of mass X is taken, a fixed quantity, whatever be the quantity. Suppose fixed quantity is M, small m. So when M, say gram, okay, when M gram of X reacts with A gram of Y, when M gram of X reacts with A gram of Y, then it produces capital A. Right? when the same amount m gram of X reacts with small b gram of Y, in that case it produces capital B compound, right? And when the same amount m gram of X reacts with small c gram of Y, then it produces capital C compound, right? Small c and this is capital C compound. Then according to this law, this ratio A is to B is to C is a simple one. Okay, the ratio A is to B is to C, this should be a simple ratio, like 1 is to 2 is to 3, like 2 is to 3 is to 4, or 2 is to 5 is to 7, etc. All these ratios are simple ratio. So now we should talk about example, right? So example is what? You know ethane, it is denoted by C2H6. Ethane is there, C2H6. Then ethene is there, which is denoted by C2H4. Then ethyne is there, ethyne or acetylene, which is denoted by C2H2. Okay, ethane, ethyne or acetylene, right? Here C2. So here also C2, here also C2. So you can see that what should be the mass? It should be multiple of 2. Or you can easily say that this, since in all these three formulae C2 is present, so mass remains fixed. So what is the mass ratios of the hydrogen? It is 6:4:2, right? Because in all the formulae C2 is present, and you know that C2 means 24. So 24 parts of carbon, C2 means 24. So 24 parts of carbon reacts with 6 parts of hydrogen to produce what? Ethane. Okay, 24 parts of carbon reacts with 6 parts of hydrogen to produce ethane. Similarly, 24 parts of carbon reacts with 4 parts of hydrogen to produce ethene. Okay, and this is ethane. Okay, I am writing here ethane, ETHANE, and this is ethene. Spelling is somewhat different. Here it is ETHANE, and C2H2, this is ethyne or acetylene. Okay, acetylene, ethyne or acetylene, this is Y. Okay, so here what is the ratio? Here the ratio is 6:4:2, that is equal to 3:2:1, which is a simple one. This ratio is simple one. So this proves the law of multiple proportions. Not proves, it is actually one example. Okay, for this case it is valid, the law is valid, because this is a simple ratio. Okay, now I am coming to the last topic of this law, that is exception of the law. If you think about the hydrocarbons means compounds of carbon and hydrogen. Okay, if you think about the hydrocarbons, and if you take the example of methane is there, you know, CH4, methane. Then propane is there, denoted by C3H8. So I am writing all these things, CH4, then C3H8. Then butane is there, C4H10. One thing is missing, I have missed to write. I am writing here, okay, in this position that will come, that is C2H6. Ethane, methane, then comes ethane, then comes propane, and then comes butane. This is methane. and this is this one, okay, the middle, this one, the next one, this is ethane, and this is propane, and this is butane. So you can see that in all these four, the number of carbon atoms are different. Here 1 is there, here 2 is there, here 3 is there, here 4 is there. And also number of hydrogen atoms are different. So if you take a fixed mass of carbon, say we are talking about only one carbon atom, then what should be the mass ratios of the hydrogen for this case? For this case, for first one, we are talking about only one carbon, so you should write this way, 4 divided by 1. Okay, then we are talking about ratios, then you just put this sign. Okay, then here 2 is there, so you write here 6 by 2. Then here 3 is there, we are talking about only one carbon, that's why you are dividing by here 1, here by 2, here by 3, and here by 4, because we are talking about only one carbon. We are taking a fixed mass of the carbon, okay? So here 8 by 3, and here what? The last one, 10 by 4. Okay, so what is the ratio? It is 4, it is 3, 8 by 3, 2.67, and 10 by 4, 5, 2.5. So you can see that the ratio is like that. 4 is to 3 is to 2.67 is to 2.5, and this is not a simple ratio. You can easily understand that this is not a simple ratio. Therefore, this is the exception to the law of multiple proportions. Okay, I think this is very easy to understand this law. Okay. And in my next class, the same chapter, basics of chemistry. You know the name of the chapter. This is basics of chemistry, okay? Basics of physical chemistry. Okay, so this was my third video lecture from this chapter. Again, tomorrow I'll post one more video, okay, from the same chapter. So in this YouTube channel, okay, you will get all the 4 subjects: physics, maths, chemistry, and biology. Okay, if you like my channel, please subscribe, and of course press the bell icon, and you know the use of bell icon. Okay, whenever new video will be posted, you will get immediately the notification of the same, and that's why you need to press bell icon. Of course, if you like my videos, then only you subscribe my channel. Okay, thank you for watching this video. Have a nice day.